Hello everyone, in today's lesson we are going to look at how to obtain the principal argument of a complex number. Now on our screen we have a problem, and in order to solve it, let us start by recalling what we mean by an argument of a complex number z and what it means for this argument to be called the principal argument or the principal angle. We are going to say the argument of a complex number z is equal to a theta, and by definition this is an angle the complex number z makes with the positive real axis on an Argand diagram. I repeat, this is an angle the complex number z makes with the positive real axis on an Argand diagram. Therefore, if I have z in Cartesian form, okay, now in order to obtain the argument of z, we need to first plot z, okay. So in order to plot z, we have to obtain the real part of z and the imaginary part of z, okay. Afterwards we get the coordinates. So the real part of z is x and the imaginary part of z, which is y. So the coordinates of z are given by x and y, okay. So we can illustrate this on an Argand diagram. So this is the real axis and this is the imaginary axis. But now we said that the real part of z is x and the imaginary part of z is y. Now when we connect the two, we shall find z at this point, okay. So we connect the origin to z, like that, okay. So by definition we said that the argument of a complex number z is the angle z makes with the positive real axis. So we are talking about this angle, and my question is, how are we going to obtain z? It is very simple. We are going to first where this is our argument, this is y and this is x. Now to obtain the value of theta, we are going to use trigonometry, okay. So this is the opposite of theta. We are going to say tan theta is equal to opposite out of the adjacent. Therefore tan theta is equal to opposite, which is y, adjacent, which is x, and theta is equal to tan inverse of y out of x, okay. Now it is clear that any angle measured in this way, we shall have multiple arguments which gives the same value of tan theta. So to get rid of this problem, we are going to introduce something called the principal argument. So we are going to say theta is the principal argument of our complex number z. If it is measured in radians, theta must lie between negative pi and positive pi. But this theta must be above negative pi and less than or equal to pi when measured in radians. Now if it is measured in degrees, this theta is expected to lie between 180 degrees to positive 180 degrees. Okay, so this theta must be greater than negative 180 and is supposed to be less than or equal to positive 180 degrees. Now, if we have this information, we are going to solve the problem on our screen. Remember, we say that z is equal to negative side of 3 plus 3i, implying that the real part of z is equal to negative root 3 and the imaginary part of z is equal to 3. So we draw our Argand diagram and illustrate z. So this is the real axis and this is the imaginary axis. But the real part of z is negative and the imaginary part is positive. So when we connect the two, we shall find z there. Okay, so we draw an arrow connecting the origin and z. So we are going to get this value of theta. Okay, but now we agreed that to obtain theta, we are going to extract out this right angled triangle. Okay, this is 3 and this is root 3. But now we need to obtain alpha. So we are going to say tan alpha is equal to opposite out of the adjacent. So alpha is equal to tan inverse of 3 out of root 3. Let's get our calculators and obtain alpha. So alpha is equal to 60 degrees. But alpha is not our argument. So we are going to say alpha plus theta is equal to 180 degrees. Reason, alpha and theta are angles on a straight line. Therefore, theta is going to be equal to 180 degrees minus 60 degrees. So theta is equal to 120 degrees. Okay, so if we want to get theta in radians, we shall say theta in radians is equal to 120 degrees out of 180 degrees times a pi. So this is equal to 120 divided by 180. This is 2 out of 3 pi. Okay. Example number 2. We have W, which is equal to negative 2 minus 2i, implying that the real part of W is equal to negative 2 and the imaginary part of W is equal to negative 2. So let us draw our Argand diagram. So the real part is negative and the imaginary part is negative. When we connect the two, our complex number W is going to be found in the third quadrant. So this is W, okay? Now we cannot take this angle as our principal argument, but instead we are going to take this one, okay? So to obtain theta, we extract out this right angled triangle. So we say that this is alpha, and now this is a 2, this is a 2. So we are going to say tan of alpha is equal to opposite out of the adjacent. So alpha is equal to tan inverse of 1, where alpha is equal to 45 degrees. But alpha is not our principal argument. So we are going to say the principal argument is equal to negative of 180 degrees minus 45 degrees. I'm saying that theta is negative. Reason being, we are moving in a clockwise direction from the positive real axis up to the complex number W. So theta is equal to negative 125 degrees. Okay, so if we want to obtain theta in radians, we shall say that this is negative 135 degrees out of 180 degrees, everything multiplied with a pi, and this is negative 3 out of 4. We're going to look at how to add and subtract complex numbers on a complex plane and obtain the principal argument of the resultant complex number. Now on our screen we have a question. If W equal to 3 plus 5i and Z equal to 3 minus 2i, find part A, Z plus W, part B, principal argument of Z plus W. Now we are going to start by representing each of the complex numbers as vectors. Reason being, these complex numbers specify their direction from the origin. Now if I start from the origin, I'm going to move 3 units along the positive row axis and then 5 units parallel to the imaginary axis but perpendicular to the real axis, implying that if I connect the arrow from the origin up to the point where we find W, we shall specify the direction like that. Okay, now if we consider Z is moving 3 units along the positive real axis and then 2 units downward. Therefore, if we draw an arrow connecting the origin to Z, we shall have it like that, where its tail at the origin and its head at a point 3, negative 2. But now we are interested in obtaining Z plus W. What does that mean? We are going to add the units of W onto the head of Z. Okay, so to add it, we are going to move. Remember that our W is given by 3 plus 5i, meaning that we are going to move 3 steps along the positive real axis and then 5 steps upwards. Okay, so this is 1 step, the 2nd step, and the 3rd. From there, we move 5 units upwards, which is 1, 2, 3, 4, and then 5. Okay, meaning that we need to draw an arrow connecting the first dot and then the last dot. And it is very clear that this arrow is parallel to this arrow. Now, if we want to obtain Z plus W, remember that this is our W. Now, if we want to obtain Z plus W, we just connect the origin up to the head of W, like that. Okay, so let's obtain W plus Z. So meaning that Z plus W equal to, we have moved 1, 2, 3, 4, 5, 6 units along the positive real axis, and then 1, 2, 3 units along the imaginary axis. And by the way, it is very clear that by addition of complex numbers, if I have z plus w, this is equal to 3 plus 5i, then plus 3 minus 2i. We said that when we are adding complex numbers, we add the real parts onto real parts and then imaginary parts onto imaginary parts. So if we try to add, we shall have something of that kind. And 3 plus 3, this is a 6, plus 5 minus 2, that is a 3i, which is the same as our answer using graphical method or geometrical method. Now remember that they want us to find the principal argument of z plus w. Now in order to do that, we have to first extract out the right angled triangle. So we draw it here. Where this is the principal argument. Theta. So I put it here. Now from here up to here, there are 3 units. So I put them there. And from here up to here, this is 6 units. But remember, if we have our right angled triangle like that, a theta here and the opposite, when we have the adjacent, we are going to use trigonometry to obtain the value of theta. So we are going to say tan of an angle theta is equal to the opposite, which is a 3, out of the adjacent, which is a 6. Therefore, theta is equal to tan inverse of 3 out of a 6. And if we place our calculator, the value of theta is equal to 26.6 degrees in an anti-clockwise direction. Example number 2. Z is equal to negative 2 plus 3i and w equal to 3 plus 6i. Find z minus w and its principal argument. Now the first thing to do is to first locate z and w on the Argand diagram. Now it is very clear that z is equal to negative 2 plus 3i, implying that from the origin we are going to move 2 steps backwards and then 3 steps upwards. So this is the origin and these are the 2 units, then 1, 2, and then 3 steps. Okay, this is our z. So we connect z to the origin simply because this z specifies its direction from the origin. Now when we consider w, for w we are going to move 3 steps in the positive real axis and then 6 steps upwards. So this is 1, 2, 3 steps, and then we move 1 step, the second, the third, the fourth, the fifth, and then the 6th. So this is our w. So we connect w to the origin using an arrow because this complex number w specifies its direction from the origin. Now our interest is to obtain z minus w, but we are going to say z minus w, this is the same as saying z plus the reverse of w, implying that if our w is equal to 3 plus 6i, its reverse is going to be equal to negative 3 minus 6i. So we are going to start from the head of z, moving 3 steps backwards along the real axis and then 6 steps downwards along the imaginary axis. So this is 1, 2, 3. Okay, then we move 1 step, the second, the third, the fourth, the 5th, and then the 6th. Okay, so we connect using an arrow. Okay, by the way, it is very clear that this arrow is parallel to this, but instead this one moves in the negative direction. Now let us obtain z minus w, and in order to achieve that, we are going to connect the origin up to the last dot. Okay, so we are going to say z minus w is equal to 1, 2, 3, 4, 5 units backwards along the real axis, and then 1, 2, 3 units downwards the imaginary axis. Okay, so now we need to obtain the principal argument of z minus w, and in order to achieve that, we are going to draw our right angled triangle. Okay, and we cannot take this angle as our principal argument. Reason being, this angle is past 180 degrees. Therefore, we are going to take this angle instead, which is theta. So when we extract out our right angled triangle, okay, the angle here is 90 degrees. So we are going to take alpha here. Okay, so this is 3 units, and now this is 5 units. Okay, so we have the opposite of the angle alpha and the adjacent, implying that by use of trig we shall say tan of alpha is equal to opposite out of adjacent. Therefore, alpha is equal to arctan of 3 out of 5. Let's get our calc and obtain the value of alpha. So alpha is equal to 30.96. But now also remember that this alpha is not our principal argument. Alpha just enables us to obtain our principal argument. So we are going to say theta is equal to negative or 180 degrees minus 30.96 degrees. I'm taking a negative, reason being I'm starting from the positive real axis, moving in a clockwise direction. And when we measure angles in a clockwise direction, we must apply a negative. Therefore, theta is equal to 149.04 degrees in a clockwise direction. Thank you for watching. Don't forget to subscribe, like and share the video for more about math.